Okay, this one is also from some past paper, but anyway, I'll put the actual year in the description. So for this one, you want to use this to obtain this. It's also possible to use this to obtain this, but I think it's much easier if you just use this. So as you can see, we have sec x there and tan x. So this one can be written as 1 over cos x minus this one will be sine x over cos x, then the square there. So I want to hold on to this square. I don't want to mess this thing up. We can expand it later. The common denominator in the brackets is cos x, then this one will be 1 minus sine x, and of course we have a square there, and then you can write this as 1 divided by 1 minus sine x over cos x squares. Others will just move this guy on top there together with the square, but I just want to show my working. So when you have something like this, means you have to reciprocate this and change the sign there. So this is the same as 1 multiplied by cos x over 1 minus sine x. So the 2 is not going to be affected, this square there, because it's cos, it means cos squared and whatever is the denominator squared. So it doesn't matter whether you put this one on top and this one on top, this one will still not be affected. So now this multiplied by this expression here will not change the expression. So we can I don't want to use the word expand, but let's just get rid of the brackets, and so this one means cos squared x, and then this one means 1 minus sine x squared. So I've just distributed the power 2 or the index 2. Yes, and then from this identity, sine squared x plus cos squared x is equal to 1. We know that cos squared x is equal to 1 minus sine squared x. So where we have cos squared x, we can write 1 minus sine squared x, then everything over 1 minus sine x squared. Okay, so we can factorize this using the difference of two squares, which states that when you have a squared minus b squared, this is the same as a minus b and then a plus b. So this is like 1 squared. So we can say 1 minus sine x, and then 1 plus sine x, then everything over 1 minus sine x squared. So as you can see, this and this is exactly the same. So to divide these two guys, we can just reduce the power by 1. Remember the rules of indices. So this and the power there, we have a 1, which gives us 1 plus sine x over 1 minus sine x, which proves the identity.